As we prepare to get started today, I'd like to encourage you to have these slides available on your own browser, so you'll have them available to use later. And there will also be some links in the slide deck that you may wish to click on. So we will copy and paste that URL so that you have that slide deck available to you, so that you can grab that and open it. Thank you so much for doing that, Rose. And this first slide is just to help you navigate this slide deck so that you can look on these slides on your own and kind of navigate it. There are also really ample speaker notes. So if you miss something I said, if you're like me and you have to multitask, so you're in a meeting and then you're also doing some other stuff and you miss something I said, chances are what I said is in the speaker notes. So there are great speaker notes here in this slide deck. So this slide will help you navigate these. Thanks again for joining us. Welcome to our session today. My name is Joy Payton, and I use she, her pronouns, and I will be leading today's session. So I've already talked a bit about ARCUS in the first session of this 5-session series. So I'm going to skip most of this slide. And I'll simply say that ARCUS is an initiative by the Research Institute aimed at promoting data discovery and reuse and increasing research reproducibility. And you can find out more by clicking on the links that are on this slide. And a little bit more about me and my group. I work in ARCUS education, and our role is to support CHOP scientists in a number of ways, but in large part by helping people acquire data science skills. And that's why we have skill series like the one you're in today. And so this team that I belong to, we do lots of different kinds of education. And we did talk about this in our first session. So again, I'll go through this slide really quickly. You can check out that link. You can also email us at arcus-education@chop.edu to find out more about what we do or to ask us questions. We're always happy to talk to learners about what your needs are. And a little bit of a reminder about what you are in today. This is a 5-session series called First Steps in R and RStudio. And so if you're brand new to R and RStudio, this is a great series for you. And we think that after you finish these 5 sessions, you'll have some experience and some confidence working in R and RStudio. And the goal is to really give you the skill and the confidence and the vocabulary to be able to keep learning on your own, to learn those specialized skills that you will need to keep learning to be able to do what you need to do in your specific role with your specific needs. So let's get started with this second session. So in this session, we are really going to hit the ground running. So you, hopefully from session 1, you already have a posit.cloud account set up. If you do not have that, it is absolutely critical that you pay attention in the next slide, because from this point on, I'm going to make the assumption that you are ready to hit the ground running with our exercise files and with your posit.cloud account already set up. So we're going to have you go into your Posit account and get working. So in this session today, you're going to have a lot of hands-on work, and we're going to talk about projects and file ingestion. We're going to talk about projects and what make them so useful, installing and loading packages, tabular data ingestion from CSV files, and we're going to talk about functions in R. And my goals for you today are threefold. I want you to be able to explain when to use install.packages and when to use library. I want you to be able to ingest data from a CSV file and examine that data using the RStudio IDE. And I want you to be able to render a quarto document. All right. So let's go on and get you started with getting ready for doing some hands-on work. So Posit.cloud is an online cloud-based service provided by Posit, and it's really easy and reliable for learners. So we talked about this a lot last week. So as teachers, we can really concentrate on our learners acquiring skills instead of worrying about the particular setups of your machine and your permissions. So using Posit.cloud is a requirement for your participation in this workshop because we cannot help you troubleshoot details of your particular computer and your particular setup and installation details. So if you already set things up in the first session, please go ahead and log in to Posit.cloud and open the project with the first steps in RStudio exercise files. If you did not set things up yet, please do that now. So there are instructions there. So please do that now if you have not already done it. And I will give you 2 minutes to go ahead and either log into Posit.cloud and open that exercise file project or get started setting that up. I'm going to add just a little bit more time to our clock here because it looks like folks maybe need a little bit more time. All right, I see that most people have given a thumbs up that they are ready to move on. If you're having any issues, let us know in chat kind of what's going on, and we'll see if we can help resolve what's happening. But it looks like folks are by and large ready to keep going. All right, so a little aside here. Excellent. Yep. I know some of you may be like, it's cooking. It's still sort of like rolling out the project if you're setting it up for the first time. So let's talk about keeping your exercise files fresh. So it is possible as we go through this series that I realize that I want to make some fixes or some improvements to the exercise files. Maybe you'll discover that there's a typo in there, or I did something that I want to fix. So if I do that, I want to make sure that you get the up-to-date changes. So because I might make changes to the exercise files, it's important that you not make your own changes to the same files with the same names, because our changes might be in conflict. So when you work in the exercise files, you're going to see that at the top of the exercise files, there's an instruction that says, before you make changes, save this with your initials at the end of the name. And please do that. Please make sure and do that so that you can have your own version. And here I have the example _Jane Doe. And what that will allow you to do is have your own version so that when I update and I make a fix or I change something, you'll be able to get the updated version, and I won't clobber, whatever version you made. So I'm going to show you what this looks like. I'm going to demo what it looks like to update your exercise files. So I'm going to go into my first steps in RStudio project. I should have done this beforehand because now it's going to take a second to resume. So in my case, I'm pretty sure that I closed all of my files before I left. So you might have a file open. If you were in here last time, you might still have setup open or something like that. I don't think I have any files that I left open. And so I say that because when I open the Get menu, my Get menu and your Get menu might look a little different based on if you have a file open or if you don't have a file open. So I'm going to find this Get menu at the top, and I'm going to click on the Get menu. And you can see I've got pull branches, push branch, history, project setup. You might have a couple of other lines there. depending on whether or not you have some files that you have currently open. I'm going to click on Pull Branches. And what that is going to do is say, are there any changes since the last time you got these files? Has the repository where you got these files from, have there been any changes? And there haven't been. I'm already up to date. So I'm just going to close, but I just want to show you what that looks like, because we're going to do that. I'll certainly do it on weeks where I know I made any changes, and I haven't made any changes, but it's possible that I might. So I wanted to introduce that to you. Let's go back to the slides, though. So before we get started working with our exercise files, let us talk about some of the common struggles that people have when they start working in R. And one of the biggest challenges that people have, especially people who do not typically work in the command line, is finding where their files are. So they may know that they downloaded it, or someone emailed them something, and they're used to just double clicking something in Outlook and it opens, and they're kind of not sure what that means or where it opens or where it saves, and they're not sure kind of where their files live. This is very common. And so working in projects is a really great way to help keep all of your data very close to your analysis script so that everything is close together in a single directory. So projects are directories. We can also think of them directories as folders that RStudio creates, in which your data and your analysis, as well as some information about your project, are all stored together in a single folder or directory. And you can have 2 or 3 or a dozen different projects, and they're all kept separate from one another to keep from mixing your files up. And this is how a lot of us are accustomed to working, right? Both in physical space, we have folders in a file cabinet, and in our computers, we have directories, right? Now, in posit.cloud, projects are the way you have to work. There's a new project button, and that in posit.cloud is by default how you must work. So it's very easy to use projects in posit.cloud. If you're working in your own computer in RStudio, it is not required to use projects. So you have to exert a little discipline on yourself to create a project, and you really should. So if you're working on your own computer, my suggestion is don't just jump in and create an R Markdown or a Quarto document. First, when you're going to embark on a new project or a new analysis, start a project. And then within that project, start a Quarto document or an R Markdown document to start working in that particular analysis or on that project. And the major advantages of using projects are keeping things organized so that you don't accidentally get things mixed up. So in my case, I tend to work on several different analysis projects at the same time. And so if you only have one RStudio session open at a time, it's kind of easy to trip over yourself. And that's because, let's say I have an object in RStudio called my_data. Now, ideally, my objects, I would call them something a little bit more descriptive, like flu trends or something like that. But sometimes, you know, we're in a hurry and we call things my_data or cleaned_data or something like that. And I could be working on 2 or 3 different projects, right? And so the person that I'm working with in audiology reaches out to me, asks for some information. I'm doing some work in my audiology project. And so I do some work in R, and my data has some information about kids who have come through the audiology clinic. And then I'm doing some work, let's say with, kidney health, and nephrology, and I'm working with nephrology, and somebody asks for some data, and I'm working with them, and I accidentally mix up my data from audiology and my data from the kidney clinic, right? Because I'm working with two things at once, and they both have my underscore data. And that can happen pretty easily if I'm working with one single session of RStudio. That is why having projects is so useful, because I can have several different sessions, different RStudio windows open. And in my computer, they're actually different icons. I use a Mac, and so in my MacBook, there's little icons on my tray, and one will say RStudio and the name of the project, audiology, and the other will say RStudio and the name of the project, kidney clinic. And that way I know exactly which project I'm in, and I can have identically named things, and they're kept separate. They're in two separate environments, two separate projects, two separate file structures, and the two projects are kept in separate sessions, and I can have things that are named identically, and they won't get confused. So I really do encourage you to use projects. It kind of comes along for free in these workshops that we're doing together because we're working in posit.cloud. But when you leave these workshops and work on your own, I do encourage you to continue working in projects in RStudio on your own desktop. All right, let's talk about importing data. So you have a project in posit.cloud, and among the files in that project, we have supplied you with some data. This is some real research data that is publicly available to get you started. And the first step in the data analysis sort of pipeline is to bring in or ingest or import. These are all synonyms. Bring in this data into your R session. So base R is the language by itself, the R language. And base R has data ingestion tools. But we tend to like and prefer to use some of the packages that have been built to enrich R and make it better. And tidyverse is what lots of people use today in R to work with tabular data. And by tabular data, I mean data that comes in table shape in rows and columns. So we're going to use tidyverse to ingest data and work with it in this series of workshops that you're participating in. And you can bring in data into R from lots of different formats, as you can see on this slide. But for simplicity and for ease in this series of workshops, we are going to concentrate on just one type of data. It is a very portable and popular type of data, and that is the CSV file. I do just want to say, don't think that R is limited to CSV. It certainly is not, but that is what we are going to concentrate on today and in this series. So CSV stands for comma separated values. And a CSV file is a plain text file, and that means you can open it in a text editor, as I've done here, and you can look at it. And this is not normally how we look at a CSV file, right? Like we normally would open it in something like Microsoft Excel or some other spreadsheet program. So you may have never done this. You may have never actually looked at a CSV in its raw format. So I like to share this so you can just take a look and see in plain text format, this is what a raw CSV file looks like. So you can see this is a bunch of values that are separated by commas. So it is literally a comma separated value file. And you can see they're all stuck together by commas. This is where in Excel, sort of the cell boundaries would be, right? So we tend to see these spaced out, right? So it's a little bit odd to see it this way. But here we see there's some human subject IDs at the far left. There's some information about the intervention they received, either a drug or a placebo. And then there's some information, some clinical information about them, like if they have ascites or edema, and there's some clinical measures like their cholesterol, their platelet count, and things like that. And this data structure is called rectangular or tabular because it falls into rows and columns, which are table-shaped or tabular. And each row has the same number of columns, and each column has the same number of rows. And in this case, you will notice at the very top, before the row that starts with 1, there is a header row. And the header row is wide. It sort of wraps around 2 lines because it's really long. But it does have a header row. And generally speaking, CSVs will come with a header, but they don't always. So in a lot of packages, including what we're going to use today, R will assume that your CSV has a header row unless you tell it otherwise. But just do be aware, sometimes in the wild, you will find CSVs that don't have a header. Be aware that that can happen. There are ways to deal with that. You can specify header names or column names if you don't have a header row. So there's data comes in a lot of formats. There's lots of ways to specify how to deal with data that doesn't fit sort of the typical format. All right, but this is a CSV. This is what it looks like. And this is the actual data you're going to be working with. And we're going to be using the tidyverse. So the tidyverse is a set of tools that lots of people use in R to work with tabular data. And we're not going to go into a lot of detail about tidy data, but the idea of working in tidy data is very central, obviously, to this set of tools because it's in the name. And the tidyverse tries to provide a consistent way to organize data and to organize code. So the goal is to create human readable code that is consistent, that provides a consistent grammar so that you sort of learn how to code in the tidyverse. And once you learn it, it's sort of easier to move from package to package within the tidyverse. And one of the most important things that it provides us is the ability to make pipelines that connect different data analysis steps together. And we'll talk about all of this in the next few weeks. And if you were in our first session, you already probably installed tidyverse and you don't need to do this. You are welcome to do it again if you want, but you might get something that says, hey, do you want to stop your session of R? And you can say yes or no. But in case you were not here for the first session and you just set things up, or something went wrong last time and you weren't able to do the setup, I did want to give you this step today. There is a setup.qmd file in your solutions folder. So you want to look in the Files tab in the lower right pane of your project, go into the Solutions folder and open setup.qmd. You'll double click on setup.qmd, and that will open up a setup document. If you did make your own setup document, ours is going to look a little bit different than yours, which is fine. And you'll go ahead and just click that play button. Again, you don't have to do this if you did it last time. But if you didn't get a chance to do it last time, or you're not sure it went well, or you had a problem, or you weren't here last time, please go ahead and do that. I will warn you that you are going to get a lot of output in your console window. That is normal. It does not mean anything went wrong because you're going to be installing not just these 2 packages, but all of the packages that these 2 packages sit on top of. So I'm going to give you a minute to do that, and then we're going to keep going. Now, I will also say this is the last time that we're going to do these setup steps. So sessions 3, 4, and 5, we're going to skip all of this setup because I'm going to assume you're all ready to go. All right, so I'm not going to slow down in quite the same way for the rest of our sessions together. All right. I don't see any issues. It could be that if you are doing this, it's still running, and that's okay. It can still run. I'm going to talk a little bit, and then we're going to do some hands-on stuff. All right, so the tidyverse is a package, and a package is a collection of functions. Functions do things in R. Sometimes some data sets that can be instructional or helpful or provide examples, and often some really useful help documentation. And packages extend the utility of the R language. And tidyverse is a kind of special package because tidyverse is a package that contains other packages. So tidyverse is sort of a meta package. It contains lots of other packages. And all of these other packages work together to do a number of different tasks related to importing data, reshaping it, visualizing data, all kinds of stuff. And there's a couple of different things you're going to want to do with packages. You can download and install a package with the command install.packages. So that's what you've already done, install.packages tidyverse. And you only really need to do that once on each computer or each posit.cloud project for any given version of a package. And you do have to use quotes around the name of the package. And after you've installed the package, it's available to you to use. But to indicate to R, hey, I am now going to use that, you have to load the package into memory using library. And you want to use library every single time you start a new R session that is going to use any of the functionality of that library, of that package. So if I know, oh gosh, today I'm definitely going to use tidyverse, so I should use library tidyverse. And usually the way we do that is that we add the library command to the top of any script that we write, where we know that later on in the script, we're going to use something from that package. So at the top of the script, I'll say, hey, later on, I'm going to use something from tidyverse, so I better make sure to use library tidyverse at the top so that I have it available. All right, so install.packages, we generally do once. And then library, we do it once per session, and that generally boils down to once per script that we write, once per document that we write. All right, so let's talk about some functions here. So read_CSV is a function that belongs to the tidyverse. And we can ingest or import CSV files reading using the read CSV function. I think my slides are a little out of order here. Are they? We can use read CSV and other data ingestion functions to bring data into our R environment. All right, so we have to bring something that's in the file system into our R environment, and we'll do that using read_CSV. Read_CSV is provided to us by tidyverse. All right, so let's go into this a little bit because this is a function. So I want to break down for you what is inside a function, what are the different parts of a function. So read_CSV is a function. Functions are defined in base R. They're also defined in packages. In our case, read_CSV belongs to a package called readr, and readr is one of those packages that belongs to the mega package tidyverse. So if we've already installed tidyverse and we've done library tidyverse, so we've loaded it, that means read_CSV is available to us, so we can use it. And you may be familiar with functions from math class where you have an input, an output. An input like is an X value, and the output maybe is the Y value. And so in our case, we have an input, a file name, and then an output, which is going to be some sort of object. So in this snippet of code, we have this function, read_CSV. It's going to take an input. The input is here called an argument. So the file name of whatever our CSV is an argument. So it's actually going to be the path to our file. And that argument is going to be passed in parentheses. And a function can have 0 arguments, it could have 1 argument, it could have 2 arguments. If there's more than 1 argument, it could have many arguments. They will be separated by commas. And then the output of this is going to be an object. So read_CSV will say, oh, you want me to go get this file, and you want me to turn it into an object, something that R can work with. And I am going to take this object and store it in a data frame. And I can call this data frame whatever I want. But it's helpful to call it something useful. I could call it my_data, but it might be useful to call it flu_trends or something that is descriptive, right? And then to move to make this output be stored in this data frame named object, we have this sort of strange character combination here, this less than and dash, which looks like an arrow. And this is an assignment operator. So that is saying, hey, will you take the output of read_CSV and please just put that inside this thing that I'm calling data_frame. So that is just a little bit of a analysis of what a function looks like and some of the vocabulary, like object and argument and assignment operator. So what I'd like to do now is I want you to spend a big chunk of your time doing hands-on work. So I'm going to steal a little bit of time for you. I'm actually going to give you just 10 minutes. So you may not, whoops, let me pause. So you may not get all of this accomplished, but I want you to take 10 minutes and then I'm going to jump in and demo this for you. I would like for you to go into your files in the lower right. I want you to go into exercises, find that exercises folder, and you will find session 2 exercise. If you open that, give it a read, and then you can just follow the directions on that file. And I want to give you about 10 minutes to get as far as you can. If you don't get all the way through, that's totally fine. But I'm going to give you about 10 minutes to do that, and then I'll come off mute, and then I'll show you a little bit of a demo of what it looks like when I do the same thing as you. So the last few seconds to finish wrapping up. All right, let me go over to my session of posit.cloud. Oop, it went asleep, so let me wake it up. And then once it wakes up, I will go into my files, go into exercises and open session 2 exercise and just sort of walk through some of this with you. And if there's anything that folks really struggled with, feel free to signal that and say, hey, I really had a hard time with this. Let me open this up. All right, before you make changes to this file, please save it as. All right, let me go into File, Save As, and I'm going to save it as. My initials are JP. All right, perfect. All right, so now I have my own copy with my changes. Now I like looking at it in source, but you may prefer looking at it in visual mode. And I got a little box here, that's fine. Okay, and visual mode may be more attractive and easier for you to read. You can go back and forth between source and visual, that's fine. And so that's what this first invitation is, to give a chance to try both. Your turn number 2 says run the chunk below. Okay, I'm going to look for that play button and run it. Okay, library, it ran some stuff below. Perfect. All right, your turn number 3. Let's see here. In case you haven't looked, look over there and look in the Files tab. All right, the Files tab is open. How would you describe the path from the exercise folder where this path lives to the cirrhosis CSV file in the data folder? Well, I don't see a data folder. Let's see here. Well, let me see. There's these things here called breadcrumbs. I can see I'm in the exercises folder. Let me go up to project. I have to go up a level to project, and then it's inside data, it looks like. So I'd have to go up to project and then down into data, and there's cirrhosis. All right, so that's what that looks like. Up a level looks like 2 dots, and then data, and then cirrhosis. So that's the file path. So let's run that. Excellent. All right, so now I have something in my environment tab for the first time. So let's see if I can answer these questions. How many observations does cirrhosis study have? Well, it looks like I have 418 obs of 20 variables. I'm going to guess that 418 obs is observations. So I'm going to say 418 question mark. And how many variables? I'm going to say 20 question mark. And then what happens if I click on the blue triangle beside cirrhosis study? Well, it looks like I've got some information about some characteristics of the data, maybe some column names. I'm just going to take a guess here. Maybe I see info about the data, like age, sex, status, etc. Okay. What happens if I click on the name cirrhosis study in the environment? Oh, well, now I get this whole big, almost looks like an Excel spreadsheet, and I can scroll over. I can, search here. What if I looked for placebo? Oh, look, it's going to show me placebo. Okay, interesting. I can experiment with that. Now, how do I get back to my original thing that I was looking at? It looks like cirrhosis study here is selected. Let me click back over here. Okay, so it looks like it opens a view of my data. All right. Some information about naming things. I'm not going to read that to you. You can read it yourself. Run these chunks. Your turn 6. What do you think each one accomplishes? So add a note in each comment. Well, let's run it and see if I can figure it out. This is IDs 1 through 6. And let me just look back at cirrhosis study. That does look like the top. 1, 2, 3, 4, 5, 6. So I think this shows the top of my data. And then, well, if that's head, I bet tail is the bottom. Let me run that. 413 to 418. Let me go up to my cirrhosis study and scroll all the way to the bottom. Yeah, that looks like the bottom. So I'm going to say that looks like the bottom. This shows the bottom of my data. Summary of cirrhosis data. Oh, that's not very pretty. Let's see if I can move some of these panels around, make it look a little bit nicer. All right. Well, it shows median and mean and max, min, first quart, second quart. Maybe this is quartiles. So summary, I think this shows summary stats. I think that's what that does. Class of cirrhosis study. Data.frame, table, table df. I think this tells me something about what kind of data it is. All right, and you can just keep going. I'm not going to keep doing all of these just in the interest of time. But this shows you different ways that you can solve the same thing. So I'm just going to run these. And you can see there's lots of different ways to do the same thing. There's a little bit of how to use help. I'll let you do that on your own time. I'm not going to demo that. This is a little bit of a sneak preview of next time, sort of a data visualization sneak peek. And then finally, let's look at rendering. When you write your code in human reasoning, you can render it. At the top of your screen, you should see a button that says render with a blue arrow. That's render. We're going to render this to an HTML. I'm going to click it. It's thinking, and I get a pop-up blocker. It says try again. All right, and now I get a nice, beautiful HTML report. All right, so that's what we did today. All right, so if any of that was particularly challenging, just go ahead and take a look at the solutions file as well in your solutions folder. Let's just go back to the slides real quick. I'm not going to go over this sort of bonus slide, but this is there for you in the slides if you want. If finding things in your file path or working with where files are is challenging, there's material there for you to look at. There's a link to a module that you might find useful. But I want to just sort of recap what we did today. So you did a lot. So, feel free to drop into chat a feeling word describing like how you felt today, or give yourself like a thumbs up emoji or a heart reaction. Give yourself some praise because you did a lot today. You learned about functions, you worked with code chunks, you ingested some data, you worked with the environment pane, you learned about working with help in R and about naming things and rendering. So there was a lot that you did today. So thank you for that. This is our next to the last slide. But I do want to provide you with a poll to sort of measure our effectiveness, because as a team, it's really important for us to measure, was this useful for you? Was this a good use of your time? So a poll should be coming up. It does contain 4 questions, so there's some pagination. So make sure that you hit that next button. And let us know, were you able to do, were we able to help you meet these goals today? And when you finish answering those poll questions, feel free to drop a question into chat. And happy to stick around and answer any Q&A. And then our last slide will be what we're going to talk about tomorrow. I'm sorry, not tomorrow, in the next session, which is next week, not tomorrow. Did not quite understand the purpose of class. Yeah. So class and type of are 2 different functions that can help you understand a little bit, what is this thing? Is this thing a data frame? Is this thing a list? Is this an integer? It can be helpful just to understand, what is this object? Great question. All right, and since we're in the last 2 minutes, let me just go to the last slide, and this is not going to prevent you from asking questions. Please feel free to keep asking questions. But I do just want to give, in the last minute or so, what are we going to talk about next time? So next session is probably my favorite session, which is data visualization. So if you have an artistic streak, I think you are really going to enjoy the next session. We're going to talk about the grammar of graphics using the library ggplot2, which is part of the tidyverse. And we're going to talk about the distinction between mapping aesthetics and setting visual properties. We'll talk about some color palette possibilities. It's going to be very hands-on. We're not going to stop and do all that posit.cloud setup. So we're really going to devote all of our time to really hands-on, juicy, fun learning. So we're really going to hit the ground running next session, and it's going to be a lot of fun. So I think you'll really enjoy next Monday's data visualization session. It's the kind of thing where you'll, walk away and you have something fun to show for your work. So I think you'll really enjoy it. I'm happy to stick around for other questions. Otherwise, give yourselves a big round of applause because you worked really hard today, and I will see you in our next session.